Okay, you've got a little lab to set up here using Google Sheets. Now, this is a convenient way to really deal with data, especially video-based data. So you can use this on lots of labs we do. So notice here I have a split screen. You got YouTube on one side and the work we'll be doing on the other. So you could actually do that. You could have this video open and have the work open right next to it. Real easy way to follow along. And for now, shrink this down a bit. Stretch us out. Now, you all got this email from me. An email here had a couple of links. This is to your school Gmail account. And so the link that would be most useful right now is the second one here. Click on this. You'll automatically get this window pop up. Now, if for whatever reason you didn't get the email, just have a friend forward it to you. Give them your email address and it will work just fine. So you click make a copy, and boom, here it is. This is your very own copy. You don't have to request permission to edit or any other business. Now, we're going to do a couple of fixes on this, so watch real quick. Right now, this is called copy of. I would change it to your name. You can make it your last name. I'll just put here Mr. B, so you know it's yours. And you can come over here. It says My Drive. Click on that, and you can actually put it into whatever folder you want. Heck, you can even create this little plus, create a folder. I have a physics folder already. I'll double click in there, and I'll go put this in my Unit 3 labs, and I'll move it here. Okay. Now, I would come down here to where it says Sheet 1, double click on that, and you can rename it Template. Leave that one alone now. We're not going to edit this one. We're going to leave it here. And by the way, if this gets too fast at any point, just hit pause, catch up, and then hit play again. A little down arrow next to template there. Click and duplicate. So the reason we do that is now we have a template that's untouched. We're not going to edit this template because you'll use this on future labs. And so you'll have this nice clean version here waiting for you. The lab we're doing right now, the one that's now called copy of template, we can double click there and rename it. By the way, you can also hit that little arrow and select rename. Call it L2.3 fan cart acceleration. And so when you're done, just click out here. Okay, good. Now, this template is set up for parallax scenarios, that's with a fixed video camera, or ride-along scenarios. In this case, we did the ride-along. The camera was sitting on Fan Cart's back as she rode along with the ruler in the image. So what you can do, we don't need the parallax scenario up here. So if you click over on the gray 1, that's row 1. Don't click in these little cells here individually, but click actually over on the bar 1. Then press the shift button on your keyboard. And then press the down arrow while holding shift. You will highlight all of the rows down through 18. They're all highlighted now. The reason we're doing that is we're going to delete them. Stay in that bar on the side there and do your right click and delete rows 1 through 18. Good. Now all we have left is the ride along scenario. Now don't worry, we still have the template that has both, but let's go to what we're doing. Got rid of the piece we don't need. In fact, let's rename this. It's not just any old ride along. It's L2.3 fan cart ride along. Hit enter, get you out of there. Okay. Now it's time to get down to business. The entire class started on a frame. What frame number was it? Well, look at that piece of paper that we recorded our data. This is from the video. We watched the video on the board and we kept track of how the ruler moved within the video and what frame we were on. So I'm going to make up a number. It's going to be the wrong number. I'm going to make up, we started on frame number 503. I know we didn't start on frame 503. We started on whatever you're on. So 503, there it is. Now what we did was every 5 frames we kept track of our data. So the next frame would be 508, and then 513, and so on. However, there's an easier way to do this. Rather than manually entering them all, if we know we're going up by 5s, you can enter a formula. Now here's how you do that. You press the equals sign. There it is. And now Sheets, just like Excel, is ready for you to give it some math formula. So what we want to do is we want to add 5 to our original frame. So you could come over here and press 503 plus 5. And of course you get 508. But that's kind of silly. That's longer than just writing 508. Instead, we want to do something that we can then copy in all of these rows down here, all of these cells. Here's how you do it. You want to take whatever frame you were on. Now, that frame is in this cell right here. That's called cell A3. So we can write A3, or we can just click on A3 and it automatically does it. Plus 5. And we get our 508. Now again, you might say, well, that's more work than just writing 508. But watch this. There's a little blue square here in the corner. Grab it. And when you pull it down, what it does is, oh, it went to 513 automatically. What this formula is telling it to do is you take the cell directly above and add 5. And so now you can drag this down all the way as far as you need to go. Now, we might need a few less or more than this. That's up to your class, whatever your frames you went up to. So stop it. If we went up to 613, let's say, you would need this 618, just delete it. Okay, good. Now, these are frames. These are not times. Ultimately, we are looking to plot distance versus time, and then a couple of other graphs. But here, these are frames. So the time, we have to make an adjustment. So first thing we can do, well, how much time has passed after the first frame? Well, of course, 0 seconds. But we want to do something better than that. We want to take the frame numbers and automatically get times. So here's how you can do it. We'll delete that. We're going to make another math formula. Equals. We're going to take our starting frame. That's A3. I'm going to click on that. And we're going to subtract our starting frame. A3, there it is. And that's going to be maybe a time. And again, you're like, well, why would I do all that? Well, then if you drag this down, that doesn't quite give us what we want. So here, this one is doing, it just updates with each row. So this one is doing A4 minus A4, but we don't want that. We want A4 minus A3. And this one did A5 minus A5, but we don't want that. We want A5 minus A3. We always want to compare it to our starting frame. So how can we make it do that? We need to lock the comparison. And the way you lock a cell in Google Sheets and also Microsoft Excel is with the $sign. So we're going to take whatever cell we're on, that's A3, and we want to subtract. We always want to subtract A3. We always want to lock it to A3. That's where we started. So how we do that is we come back to our little formula and we put a $sign in front of the A and a $sign in front of the 3. And now it'll lock it in. Now I know this gets a little finicky here. Let me zoom in so you can really see what's going on. So what we did was we took wherever we are, that's A3, and we want to subtract always this starting frame. $sign A, $sign 3. That $sign locks it into this cell. And now when we copy this down, look what happens. So this one, if you look at the formula, still subtracted A3. And then the next one, if you look at the formula, still subtracted A3. So we're on the right track here. Now notice, of course, these are not times. These are number of frames. It did not take 10 seconds to get from frame 503 to 513. It actually took a small fraction of a second. So now we have to do a little dimensional analysis, a little conversion. We have to convert from, these are actually the number of frames that have passed. Notice here, this is the frame number. And this is actually how much that frame number has changed compared to the original. We still have to turn that into a, let's see here, into a time with seconds. So one way to do that is very simply with dimensional analysis. Now we've done this in class many a time, and I know it's a little bothersome to look at here, but I'll show it to you. While that's going, you can also, Microsoft Word's popping up for us, you can also now enter in your distances. These are manually entered. There's no trick to entering these. So when you enter these, you have to look at your loose leaf sheet. Your first distance was definitely 0. Your next distance was some other number. Now, I have one student's video distance from one of the classes. Your numbers are probably not going to match these numbers, but here are the numbers that I have copying one student from one of the classes. Let's see here. Don't worry about what I'm doing. I'm just copying theirs over. You have to write yours in. So I copied all these over. Good. Now, your distances will most likely not match these. They're not going to be terribly far off, though. They should roughly be in the vicinity of these numbers. So you're going to complete a full list here. In fact, pause the video and complete that list. All right, now hopefully you're back. And I can give us a Word document. The reason a Word document is going to be helpful here is we have something called Equation Editor, and that allows us actually to see how to convert frames. Here we go. So let's take, for example, this one here, 5 frames. How do you turn 5 frames into seconds? Well, if you remember, 5.00 frames, what we did is we multiplied by a fraction. So put a little, the way we did it in class, you put your parentheses, and in that set of parentheses, you put a fraction, and increase the font size a little bit so you can see this better. Now, of course, then we put our units in, frames, on the bottom, and we want to turn this into seconds on the top. And of course, the question is how many of each? Well, we used a camera that had a frame rate of 60, which means 60 frames per 1 second. That's over here. I programmed that in. I'll show you how to do that in a minute. So what that means is you put a 60 next to your frames and a 1 next to your seconds. And what you'll see here is the frames will cancel. Make this a little bigger. The frames are going to end up canceling. And what you're going to be left with is seconds. But realize what's happening over here. This is nice to write on a piece of paper. Microsoft Word's not going to do the math for us. But effectively, you're doing 5 times 1 divides 60, which is really just 5 divides 60. So what that's telling us is, how do we turn? So this is how to convert frames to seconds. You're basically going to divide by 60. So come back over here. That's what we have to do. We have to take our entire calculation, so put parentheses around it, and divide it by 60. Now that may look the same, but watch what happens when you drag it down. Now those are seconds. That's actually what we want. So, one thing you can do, if you would like, is hardwire in, instead of hardwiring in that 60, you can actually reference this cell up here. So what I just showed you, you're good to go. Copy all the way down, be done with it. There's all your times. Now your times actually, though your frames won't match mine, your times should match mine. Your time should look exactly like this. Now you may have gone a few more or a few less, but all the times here should match. Now for those of you who kind of like this stuff, one way you could set this up so that you can always adjust the frames and all these will adjust for you. This is kind of like H level right now. You don't have to do this. Is instead of calling this 60, you can call it what we wrote in cell B1. So we can replace this with B1. And you get the same thing. And then when, uh-oh, what happened? Remember, anytime we drag down, it automatically updates. So you saw here it was B1. The next one then will be B2. And the next one will be B3. We don't want that. We want it to always compare to B1 up here. So we got to lock it with the $B, $1. And then when we drag that down, you will see everything looks exactly as it did before. The only benefit of this is actually a sizable one if you have a lot of data. If your frame rate changes from 60 to 120, well, all you have to do is come up here and change this to 120, hit enter, and all the times adjust automatically, which is a nice thing if you're doing a lot of stuff like this. But for right now, we're going to leave it on 60, and you didn't have to do that part if you didn't want to. All right, so now we're kind of in good shape. Our data is more or less ready to go. So the last bit of business for us to do is figure out the slope and the slope of the slope. So if we come over here, slope is always delta y over delta x. We can't actually do it in box 1. We have to go down to, rather this is cell D3, because the slope requires a change in time. So you need to at least start down here. In this very first cell, we have no change in time yet. By here, this second row, this row 4, we actually do. And it's very easy to do slope. It's nice here. You press equals because you want math. You write slope, parenthesis. Now it says here data y. That means delta y. You can highlight these two cells, or you can literally write C3 colon C4, then put a comma. Now it wants the delta x. Put that right there like that. Close the parenthesis. So you could either highlight it the way I just did, or you can literally type equals slope parenthesis C3 colon C4 comma B3 colon B4, close the parenthesis, press enter, done, there's a slope. Now your answer may not match mine. That depends on your distance. If your distance matches mine, it will. If it doesn't, it won't. We want all the slopes all the way down, so down we go. We grab that little blue box. Again, we grab that little blue box here, drag it down, and there's all your slopes. So it looks like mine went from roughly around 1, and it goes all the way up to about 25. Just so you know, this is distance. The slope of distance, which in calculus you'll call d prime. The slope of distance is what? You're supposed to know this. That's right, v, speed. So we can put a little equals v up there. I know the formatting looks funny here, so if you'd like to clean this up, put your mouse right back in front of that parenthesis, and on your keyboard there, hit Control Enter. And that actually lets you format down until the next line within a cell. It's a nice little trick. Now we're going to do the slope of the slope graph. And that one, we call that d prime prime, or d double prime in calculus. Basically that means not the slope of the distance graph, but the slope of the distance, which is the slope of the speed graph. That should be acceleration. Now again, this is using the speed values. So we can't start here yet. We need a delta y. We're going to have to start one more box down. We're going to have to start in E5. So same thing, equals slope, parenthesis. We can do these two, D4 to D5, comma, back to time now. Don't put the distances in there, put the times in there. So you're doing B4 to B5, close that parenthesis. You stretch this over a little so it don't look as weird. There you go. And press enter. There it goes. Okay, now grab that little blue box, drag it all the way down, and there you go. In fact, I know some of you kind of like this stuff. If you really want to get a little wild, you could come over here and put a slope of slope graph, which is D triple prime. And what is that? What's the slope of the acceleration graph? Oh yeah, that was jerk. If you want to do a little bonus, you can do the jerk graph. I'll show you how. Now you can't start here. You need a delta y. You got to go down to this spot, down to F6 equals the slope of, do your delta y's will be the accelerations, comma, and go all the way back. We're always comparing to time. So there it is. Move this over a little. Enter. And I know that number looks funny, but don't worry. You'll see there is some meaning. Drag this all the way down to the end. And there's some funky looking magnitudes or funky looking direction and magnitude on those, but that's okay. And that's it. So let me zoom back down. So here what you have done is you have entered frames from raw video. We have converted those frames into times by comparing to the original frame and by adjusting by the frame rate. You have manually entered distances that you read off the video. And then you calculated slopes of those distances. You used the slope of the distance column and the time column, and that gave you velocities or speeds. Then you did a slope of slope, so you did the slope of the speed column with the time column, and that gave you accelerations. And then if you really wanted to, a little something extra over here, you could do the slope of the slope of the slope. You could do the slopes of the accelerations with the times, and you get some jerk data. So our next step, which you are going to have to do, is graphing. So let's pause right here and make that a second video.